In this video, I'm going to look at the maximum velocity for skidding and overturning. That is, if a vehicle must stay in track, going around a circular track or around a bend, if that vehicle will not skid or must not skid, what is that maximum velocity it must be driving at? Because if this velocity is exceeded, definitely this car will skid or overturn. So in this video, I'll be deriving an expression for the maximum velocity for skidding and then for overturning. And here you have a car on this track about to go around this circular track. And let's say the forces acting on this car. The car, let's say the two tires of the car are A and B. There are normal reactions, normal forces acting at each car. N1 is acting at the inner wheel of the car, then N2 acts at the second tire, that's the normal forces. Then we have the weight of the car, mg, which is acting vertically downwards. And this 2a is the distance between the two tires. Now, the center of gravity or center of mass of the car is this point G. Of course, that point G is the point where the entire weight of the car appears to be acting. And again, it's also taken as the center of mass M. So this center of gravity is h meters above the ground. Okay, at the two wheels of the tire, each of them is distance A from the center line, that is from G. So which means the distance from this point to this point is A, and from this center to the second wheel is B. Now there are frictional forces acting on the two wheels. The first one is M1 acting at the inner wheel, that is the frictional force between the inner wheel and the ground or the road. Then F2 is the frictional force acting between the outer wheel and the ground or the road. Okay, so these are the forces acting, and we are going to use this to try to establish the formula for the speed, the maximum velocity of a car, in order for it not to overturn or to skid. Now here I have the forces laid out, written down here, normal reactions, and they act vertically upwards. The frictional force from both wheels, F1 is given by coefficient of friction multiplied by normal force N1, and F2 is given by this multiplied by N2. All right, the weight of the vehicle of the car acts vertically downwards. You can see that in the arrow there. And the centripetal force that is needed to keep this car moving in that circular track, I call that my F, capital F, and is acting towards the center of the bend. Now, let's see the motion. Vertically speaking, let's resolve the forces acting vertically. We have the normal force N1 plus N2 is equal to the weight of the car. If we check here again, that the two normal forces are acting upwards. So we can equate that to the downward force. Why are we doing that? Because vertically speaking, along the y direction, there is no motion. It means that the two normal forces, N1 and N2, they are balanced by the weight of the car, mg. Okay, so for that, we have this, and this centripetal force is provided by the frictional force acting on both tires. So if I say F is my total frictional force, it is equal to the sum of the frictional forces F1 plus F2. These frictional forces are both, acting in the same direction. So F1 acts at the interface, the contact between the inner wheel and the road, and F2 acts between the outer wheel and the road. So the sum of the two forces gives my total frictional force, and which provides the centripetal force. So which means I expect that this frictional force should be greater or equal to the centripetal force, which is given by mv squared over r. Recall that r is the radius of this circular track. The center of this track will be around here. So the distance to the center here is my radius, that is from the road to the center of the track. Okay, so we also know that F1 is equal to mu N1 and F2 equal to mu N2. So I'm going to be making my substitution in the above equation. So I'm going to have mu n1 plus mu n2 is greater and equal to mv squared over r, okay? So if I factor out the coefficient of friction mu into n1 plus n2 rather, that is greater and equal to mv squared over r. Now, if you go back to the first equation here, call that equation 1, the sum of the normal forces m1 plus m2 gives us mg. So I'm going to have mu, I'll replace this with my mg, that is greater or equal to mv squared over r. It's the same vehicle, so the masses will cancel out. So we can also write that v squared over r is less than or equal to mu times g. So if mu g is greater than v squared over r, it therefore follows that this is less than this, okay? So that's how I write it that way. Now, so that my maximum velocity v squared maximum will be equal to mu rg if I cross multiply, so that v maximum is equal to the square root of mu, coefficient of friction, radius times acceleration due to gravity, which in most cases is taken as 10. Okay, so if skidding will not take place, then it means that this must be equal to this. If the speed of the car exceed this times this, definitely that car will skid and it will veer off the circular track. So that is a condition for the vehicle not to skid, to prevent skidding. The maximum speed must be equal to the square root of this. I think that have been derived before my previous video. Now, to prevent overturning, I'm going to still show you the model, the picture of this vehicle that is going around this bend. To overturn, it means that this inner wheel will lose contact with the road. So when N1 becomes equal to 0, this car overturns. And there's a certain speed at which this happens. So to prevent N1 being equal to 0, this vehicle must drive at a certain speed limit to prevent overturning. The N1, that is this wheel, loses contact with the ground, loses grip with the ground, and so this goes to 0. So how do we show that N1 must be equal to 0? Now we come back to the vehicle again, and then we're going to take rotational moment about point G. Remember that moment is the product of the force and the perpendicular distance. Moment produces turning effects. So let's come back again to look at the forces acting on this car. So first, of course, we know that vertically speaking, N1 plus N2 is equal to the weight of the car. We've also established that the frictional force F, which provides the centrifugal force, is equal to mv squared over r, okay, where r is the radius of the track. Now, taking moment, if I take moment about the center of mass G. Of course, you can see clearly here that the center of mass of the car is at this point and it's at a distance h from the road. That's like the height of the center of mass. And the normal forces N1 and N2, each of them is at a distance a from the center of mass. That is, if this is the center of mass connected from this line, this is my distance a, then this is also my distance a. So each of them, that is N1 is a from the center of mass, N2 is also distance a from the center of mass. All right. So if I take moment about G, you come to see that N1 will produce a clockwise moment because it makes the car to turn in the clockwise direction about point G. If only N1 were to be acting, this car turns its way. Okay, another force that the total frictional force acting in this direction, because the frictional forces from the car tires, F1 and F2, they act in the same direction. So the sum is F, call that F. Now this F will produce a clockwise moment as well about point G. Okay, so for clockwise moment, let's write for clockwise moment, we should have that N1 times A Yes, because that is a perpendicular distance measured from the line of action of M1 to the center of mass M or G. Okay, so this F, which is the total frictional force, the perpendicular distance of this force from the center of mass is this distance h. So that's what I can say this is plus F times h. So that gives a total clockwise moment. Now this N2 will cause the car to turn in this direction. So my anti-clockwise moment, about the same point G is N2 multiplied by A. A is still the perpendicular distance. Okay, for equilibrium, if this car must not turn, it must remain in the state of equilibrium. It means that N1A plus FH must be equal to N2 times A for equilibrium, or N2A must be equal to N1A plus FH. Recall that this F is also equal to our centripetal force. Alright, so let's say we want to find, recall what I said earlier, that if this car, is about to overturn, it means that this particular wheel loses contact, loses grip with the road, meaning that the normal force N1 becomes equal to 0. Okay, so let's say I have this equation. Okay, let me label this equation 1. I want to solve these two equations or these three equations simultaneously. N1, equation 1, equation 2, and equation 3. This is my equation 3. Okay, so to solve them simultaneously, I have to write N2A, bring this to this side, minus N1A is equal to FH. I'm writing equation 3. Then I want to solve that with equation 1. I'll have N1, or let me write it this way, N2 plus N1. Remember that N1 plus N2 is equal to N2 plus N1 is equal to mg. Alright, so to eliminate this, let me multiply equation 1 by A. So I have N2A plus N1A is equal to mga. Okay, call this equation 4. So let me add equation 3 and 4 together. I'm going to eliminate this so that I have 2N2A is equal to FH plus MGA. Okay, 2N2A. So I have N2 is equal to FH plus MGA divided by 2 times 2 times A, 2A. Now this is for N2. Okay, likewise, we want to find N1. I have to subtract these two equations. Okay, I want to find NA. I'll subtract equation 3 from 4. So this is gone because N2A minus N2A gone. Then minus this gives me minus 2N1A is equal to FH minus MGA. Okay, so I can write, take the negative side to this side. I have 2N1A is equal to MGA minus FH, multiplying through by negative sign. Okay, so that my N1 is equal to 1 over 2 A into MGA minus FH. Recall what your F is. F we know is centrifugal force given by mv squared over r. Okay, so when I make substitution in that equation, what do I have? Okay, come over here now. I'm going to have N1 is equal to 1 over 2A into MGA minus mv squared over r times h. Okay, since I can divide each term by a, so I have N1 equals 1 over 2, I can factor out m over 2 into g minus v squared h over ar or ra. Okay, I guess you understand what I've just done there. I factored out m, and then this a divided by this divided by a. So at this point, for n1 to be equal to 0, It means G minus V squared H over RA or AR must be equal to 0. Because as you see that as the speed of the car increases, the normal reaction N1 decreases. So which means this car increases to a point where the whole of this term becomes equal to G. And this minus gives you 0. That makes N1 equal to 0. So it means that if the limiting value of N1 or V must be such that this minus this is equal to 0, or V squared H over AR or RA is equal to G. Cross multiply have ARG is equal to V squared H, so that my V squared equals to ARG over H, and V must be equal to maximum value of the space so that the car does not overturn, must be A, which is the distance of the wheel from the center of mass of the car, radius of the bend, the value of center of gravity G, and the height of the center of mass. Okay, so this must be the case. So, but if this velocity exceeds this value, it means the car will overturn, because at that point in time, the normal reaction, N1 acting at the inner wheel, goes to 0. Okay, and the car overturned. All right, so that's another way of looking at it. Another way of proving this is that N1 plus N2 is equal to mg. Okay, I've already shown this before, and that I have from taking moment, we have N2A is equal to N1A plus FH. Okay, and that F is equal to mv squared over R. We said if the car was not overturned, or the point is about to overturn, this term becomes 0. N1 is 0, so that N2A is greater than or equal to F times H. So recall that from equation 1, if you set N1 to become 0, it means N2 equals mg. You can make substitution here, have mga greater or equal to F, which is my mv squared over R multiplied by H. Okay, so I can now cancel out the masses so that I have a cross multiply, or I can write V squared H over R is less or equal to GA. Cross multiplying, I have V squared is equal to GRA. Cross multiply divided by H, and then I take square root to get my maximum speed. Okay, so maximum speed, so that the car does not overturn, is square root of GRA over H. So in the next video, we shall solve a very practical question with these equations I have proved.